Start. Black, green, there we go. Hello and welcome to Calculus 2. Our official first class, first section 6.2, area between two curves. You are familiar with the concept of computing the area under the curve. Now, area under f of x, let's say between a and b, is actually trapped between two functions, but we never said that before. You see, as I color in this area that we are interested in, note that the top of this area is bounded by f of x, and the bottom is bounded by y equals 0, and the top is bounded by y equals f of x. So your good old integral that you know from Calc 1, a to b of f of x dx, is actually f of x minus 0 dx. And yes, before anyone asks, those parentheses are necessary there. Why? Because it's times dx. Very good. There is multiplication. It's the height times the width, right? So you already see that you can think of this as a function on the top, and the other one, the minus 0, as the function on the bottom. That will help us greatly when we consider the Calculus 2 case, which we are thinking about today, which might look like this. Observe that you have f of x function on the top and g of x function on the bottom, having the area trapped in between. So we are interested in this area. Also observe that these intersect, and naturally those should be your A and your B. So I would say, looking at this minus 0 here, that it should be the common sense to say that the area between two curves is integral a to b. Restart it? Yeah. Okay. Of f of x minus g of x times dx. Just want to check the health on it. Oh, it shows it's green. So now, this is the formula. I'll put this on a cloud. Now, why does this work? Well, think of eating a banana. What do? You peel the banana, you eat the middle part, and you throw the peel, right? So imagine this part here, all of this here is the banana. So if you are computing just integral of f of x, you are going to get everything from f of x all the way down to 0. And then, when you compute integral of g of x, you only get this part, which is the banana peel, right? So when you subtract everything minus the shaded portion there, you will be left with the green, right? Which is the area that you're looking for. So everything minus what you don't need, then, right? So the formula makes sense. Certain problems will have to be worked out using dy. So we have the form for dy, where area is going to be integral c to d, because those numbers are on the y-axis, of f of y minus g of y dy. And a little graph on the side, just to make you happy. Now, we use the representative rectangle to determine which of the two, dx or dy, is the appropriate one for the problem. What is important is, I'll go back to the x first, is that if you draw the representative rectangle, it is important that the top always slides on one function from a to b, and the bottom slides on the other function from a to b. And if you have these functions like this, clearly dx will not work. Because if I draw dx, look, in this instance here, dx is touching the same function. And that makes a 0, right? So this one on the side, which is the one I have below, must be dy. Because observe what dy does. This one always slides on the left function, and the other one always slides on the right function from c to d. So it is very important to understand how this representative rectangle helps you set up the integral in the first place. So representative rectangles move from a to b, those are your limits, and then it's top minus bottom, function on the top minus the function on the bottom. For your dy, it moves from bottom up, c to d, and it's going to be right minus left. Think of x-axis and y-axis as the default position. So it's going to be further away minus closer by, if you want to think of that way. So if y-axis is the default state, function that is further away minus function that is close by. If this shape was on the other side, then this function would be first and that one would be second because the shape's here. So for both of these, at least this is how I remembered it when I was a student before I figured out all of this differently. I remembered far away minus close by. And it works for both. Because top minus the bottom, right? This is further away from x-axis. And then right minus left. Again, further away minus close by. So you always take your x and y axis as a reference point, and then from there you say further away minus close by. And the only thing that you have to worry about is if these functions start intersecting. Because if you have a situation like this, where one function does this and the other function does that, A to B to C, there I say clearly f and g and g and f, we must have two integrals for those. Because a single integral cannot solve it, because this is f is on top and g is on the bottom. This is f minus g and this is g minus f. So there will be two separate integrals, a to b and then b to c, added together for the total area. Make sense? Perfect. So I'm going to write formula for that, but I can't draw every possible combination there, right? Because they might intersect 5 times. Then you have five integrals, right? 4 integrals. This is 3 intersection for 2, it's n minus 1. So area in this case is integral a to b of f minus g plus integral b to c of g minus f dx. And we're done with Calc 2 portion. The rest of this section is you working out examples, which is you use Calc 2 to set it up, use Calc 1 to solve it, right? Because you know how to integrate from Calculus 1. What kind of integration? It's either going to be basic or it's going to be U sub. You don't have anything else at this point. After chapter 7, it will be richer ground, right? Trig is going to be there, right? E is going to be there. Ln is not going to be there because you learn how to integrate Ln in chapter 7. But integral of 1 over x is what? Ln, yeah. So you might be computing with Ln, but you will not be integrating Ln. So this is what my classes are. Now you get busy with examples. So first example is going to be this one. So find the area here's your x squared graph, and here's the linear graph. Now this linear graph seems that cuts here nicely and cuts there nicely, so that's a 3, and that's 5, 1. How would you figure out A and B, the limits of integration? Set equations equal to each other. Very good. Great. Come on, let's go while we're still young. Set equations equal to each other, figure out A and B. Then set up the integral top minus bottom. Use the limits A and B you found, and figure out the area. And if you're not writing in your notebook, I'll give you the marker to write on the board. I'll do the balls at that point. I can know exactly. 17 seconds left. All right, time is up. We are going to set two equations equal to each other to figure out the limits for integration. So a and b, our a is over here and b is over here. So that's x squared is equal to the equation of the line. The slope is, so we have a 0 and 3, so that's going to be 2 units down. So negative 2 over 5 units across, x plus 3. That's our equation. And we move everything to the same side. Multiply by 5 to get rid of the fraction, and then hit it with a quadratic to get the values. So negative b plus minus b squared minus plus 4, that's 300, I hope, over 10. So that's negative 2 plus minus square root of 304 divided by 10. So those are exact limits. Now those are going to be some ugly decimals because obviously I just put whatever there. To find the area, we will have integral of negative 2/5 x plus 3 minus x squared, which is on the bottom, times dx. Note the double use of parentheses. I don't have to have this many parentheses, but I did. And then we have the lower limit, negative 2 minus root 304 over 10. And the upper limit is negative 2 plus root 304 over 10. And all of this is equal to a number at the end, which is the area. And we're done. Now you can get the decimal for the limits and you can compute all of this if you're interested in those numbers. I'm not interested in that. That's Calc 1. We need to know that we need to set equations equal to each other to get the limits. We need to know that it's top minus the bottom to solve, to set up the integral, and then unleash Calc 1 to get the rest done. Great. So that takes care of that. My account is locked again. Why? All right, who's gonna log in? So just type in your G number and the thing I got. just need to access the textbook. All right, thank you. All right. Believe it or not, that's it for 6.2. I just want to pull 2 problems from homework section to work on it. The ones that you will be able to find the number at the end. I'm just realizing that a lot of you guys actually have textbooks, which I could have taken. And the reason why I'm logging in here is I use the online textbook. I don't drag paper with me.
I got a quick question for you.
Yes.
If we do this on my math lab, would they want us to do the exact numbers and then like the exact percentage upon the decimal and all?
Well, usually it specifies, if it's a decimal answer, it specifies. But most of the time, you should just leave it as is, like e squared minus 5 should be the exact answer, and you leave that. Unless they say round to the nearest 100, that means 2 decimals.
Okay.
So it depends from problem to problem. It depends on what they ask for. Generally, my MATLAB is very, very particular about that, and the correct problem might look like it's wrong. So if you are 100% sure you're solving the problem right, but the MATLAB keeps telling you it's wrong, make sure you guys talk to me. I will check that and make sure, because, it happens. All right, I have the textbook now. All right. This is problem 55. That's a bit spicy, but you got this. Talk to people around you if you like them. Try to work it out together. So it's a parabola and then a linear line. Parabola has x equals y minus 2 squared divided by 3, and the linear line is y equals 8 minus x. Clearly we're looking for the area in here. Obviously 44.5. Yeah. Yeah. Sorry, I have to. got it. You got the concept, so just be careful. I had a class with 3 maths. That was amazing. Math, won't be yes. All right, let's take a look at this. So the first order of business is to figure out if we are going to use dx or dy. And I will draw dx because I would like to use dx, but then I have to be careful because if I draw dx here, I see that it collapses on the same function. So it cannot be dx. We have to walk away from dx and set dy. And now dy seems that it will work. If we are using dy, that means that all functions have to be in terms of y, because this guy over here is x equals f of y. Now, luckily, one function is already given as x equals f of y. We just need to massage the other one to get in the same form. So this one over here is now going to be x equals 8 minus y. So now, set two equations equal to each other to find the limits. We have y minus 2 squared divided by 3 is equal to 8 minus y. That is y squared minus 4y plus 4 equals to 24 minus 3y. And when we put all of this on the pile, we get y squared minus y minus 20 equals to 0. Now we can factor this one, I hope. That's y minus 5 and y plus 4, which gives us that y is 5 and y is negative 4, and there are the limits. To set up the integral for the area, the lower limit is clearly negative 4, the upper one is 5. And then we go linear minus quadratic. So 8 minus y minus y minus 2 squared over 3 dy. Which is equal to integral negative 4 to 5. And then we have parenthesis 8 minus y minus 1/3 times y squared minus 4y plus 4 dy. And then we can distribute and combine like terms. So a little bit of calculations with fractions. So you can calculate them separately. I mean, you can integrate here each term if you want to. So we have negative 1/3 y squared. Then I have positive 4/3 minus 1 is plus 1/3 y. And then negative 4/3 8 minus 4/3, that's 20 over 4, which is 5. Is that correct? No, that can't be correct. 8 times 4, that's a 32 over 4, and minus 4/3, so 28 over 4. Dy, I will integrate, get negative 1, oops, I'm integrating now, get negative 1 over 9 y cubed plus 1 over 6 y squared plus 28 over 4, that can cancel. No coughing. That's a 7y from negative 4 to 5. So what's the number at the end?
It was 90 over, or no, 81 over 2, or 40.5.
Yeah, 81 over 2 is a good number, as you predicted. Good. No, the next one is, this one is. That's it. I hope you're not disappointed. So far away minus close by, and set the equations equal to each other to get the limits. Set it, and just before you do anything, decide whether it's dx or dy. I'm going to stop the stream and restart for the next. We're going to have a break, and then we'll restart in some time.